Thanks for coming out, everyone. I have a bit of a confession to make. I have been doing Kotlin for quite a long time. I was using it in Android apps probably well before I should have been putting it into production. And I've been doing the same thing on the server side behind my client's back, whether they know it or not. And I've learned a lot. It's been really fun, really exciting, really rewarding. But today, in particular, I want to talk about a technology that's probably a little newer to the JVM and particularly the Kotlin world, and that is GraphQL. And I want to talk a little bit about how you can build really robust server-side APIs using GraphQL. So in terms of what I'm going to cover today, so first I'm going to talk about what GraphQL is. Not everyone here may be familiar with it as a technology, so we're going to do a little bit of an overview. Then I'm going to talk about some of the reasons why you might want to consider using GraphQL, whether you're starting a new project or whether you want to start integrating it into an existing project. We're going to talk a little bit about the workflow on how to use GraphQL, because the way that you develop a GraphQL API is a little different. If you built any other REST APIs, RPC, the workflow is slightly different. We'll then going to talk about why Kotlin and GraphQL go so well together, what the benefits are. And finally, we'll do a little bit of a demo and we'll look at what kind of the client-side experience is of GraphQL. And in particular, I'm going to kind of ask you some questions along the way about problems you might have, and then I'm going to show you how GraphQL solves some of those problems. So first, what is GraphQL? So if you go to the website for GraphQL, you'll see this statement. You'll see it is a query language for your API. Pretty bold, pretty interesting, powerful marketing statement, but let's kind of get into it and unpack what that really means. So first and foremost, GraphQL is simply a specification. I would encourage you to actually go to the website and read the specification. It's actually written in plain English. It's pretty short. You can get through it pretty quickly. And like any, fairly significant technology that's going to be powering your API, you should have at least some understanding of how it works under the hood. And as far as, again, the specifications go, it's written in very simple, plain and clear English. It's not like if you were to try and go read the HTTP spec and you'll come out very dizzy. I would encourage you to go ahead and do that. But GraphQL, first and foremost, is a specification. And I like to divide the major parts of GraphQL into three distinct pieces, or three distinct components. So first, GraphQL is a runtime. There is an engine that parses and executes your queries in a standard way, which is part of what's in the spec, right? You also have the schema, and the schema is basically you describing to the runtime what can be executed, okay? Finally, you have your type system, and this is where GraphQL derives a lot of its power, is from the type system. You describe your data and its relationships to GraphQL via a schema and into the runtime. And we'll take a look at what that means in a little bit. So that's what GraphQL is, and those are what the components are. Let's talk a little bit about what GraphQL isn't, because that is pretty important too. So GraphQL is not a framework, right? Again, I said before, it is a specification. GraphQL is not a framework. There are implementations of the specification in a number of different libraries, but it's not a framework in and of itself, right? It's meant to be a technology that integrates and exists with other pieces of technology, and it's very agnostic to a fault, and we'll talk a little about that. It's not an HTTP pattern. You will see GraphQL typically exposed over HTTP, but if you go and read the specification, it actually says nothing about how you should expose your GraphQL API. That means that you can run it over RPC, you can run it over HTTP if you'd like, and they actually have some ideas and some recommended ways to do that to make people that are writing client frameworks that interact with GraphQL kind of interop. But it has nothing to do with HTTP. You could embed a GraphQL runtime in an Android app and call it directly like a function, okay? And last, it's not tied to any storage mechanism. It's not tied to any particular way that you might store or get your information. It's completely agnostic, right? It is agnostic to a fault. That causes some issues with it, but this part in particular allows you to integrate it very, very, very easily into anything existing that you have. So we know a little bit about what GraphQL is and what it's not. Now let's talk through a few reasons why you might want to consider using it and some of the benefits. So first and foremost, GraphQL is an incredibly flexible protocol, and I talked about this a little bit earlier, right? But it does wonders in terms of working with your existing code. It's very interesting to go back and look at the history. GraphQL as a specification came out of Facebook. Obviously, Facebook has a ton of code server-side, and in order to move to GraphQL, they had to put GraphQL and figure out how to integrate that with their existing system, right? So keep that in mind as we go a little further, right? It's incredibly flexible, and it's very, very easy to integrate with your existing code. The second thing is that because it's a very flexible protocol, it can help you actually identify and address certain over and underfetching problems. In particular, overfetching is a performance problem that you might encounter, say, if you're using an ORM in Spring, depending on if you're getting things eagerly or lazily. The protocol itself helps you identify when you might be overfetching or underfetching your data. Second, GraphQL is introspective. So this is where the ecosystem around GraphQL really derives a lot of its power. So you can query the server for the types and the data that it supports. So if you are coming from a world where you use Spring or Ktor or Vertex or any of those frameworks, you write code and you kind of put that in the framework, but the framework itself really doesn't know about your data, right? In this case, and in GraphQL's case, you tell the runtime with its schema and your types exactly what it is. And so what happens is then the ecosystem around it can allows the ecosystem around it to provide really robust tooling and automation on top of your server, and it can react to your server when it changes. Okay? And we'll take a look at that in the demo. So it's self-documenting, and we'll talk a little bit about this because the workflow about how you build a GraphQL API is different. The schema and types are validated and documented up front, right? You cannot use GraphQL, you cannot run a GraphQL API without first defining your schema and its types. And because it has all of that information up front, it can provide really helpful error messages at runtime when things do go wrong, okay? GraphQL is also versionless, and in some cases it can actually make versioning easier and more performant. So with GraphQL, say you are wanting to add a new field or wanting to change a little bit of the structure of a given type, you can do that without affecting your clients because the clients ask for and get only what they request. So if you go to add a new field and that field is potentially expensive and you don't necessarily want to just throw that out there and have all of your clients have to get that when they hit an endpoint, that's okay because you can launch it. And since all the clients can opt in to grabbing that expensive field when they want, you don't have to worry about that, or you can at least plan for it anyways. So inverted control, and this is a big one. This is one of the areas in which GraphQL really shines. Clients can customize the structure and the fields that it gets back. And requests and responses are mirrored. So let's take a look at what that means. So if I send a query to the GraphQL server, and I say, give me the user, give me the ID, and give me the name of that user, the response that I get back mirrors that query. So I know exactly what I'm getting back because I sent it to the server. Okay? This helps tremendously when you are trying to support multiple clients that have different requirements per their views. So if you're building a tablet app, a web app, a phone app, they all might have very, very, very different requirements in terms of what that API does. GraphQL allows you to grab everything you need and batch that up in one single request. Okay? So how do you use GraphQL? How do you build a GraphQL API? What are the steps to do that? So I mentioned before, GraphQL, when you work with it, it's slightly different. You have to go through kind of a different set of steps. The first thing you have to do is you have to create a schema and you have to define your types and your fields. You have to explain the relationships between your data. You then have to explicitly define the queries, the mutations, or how someone is allowed to change that data. And then there's also something in GraphQL called subscriptions, meaning this is you can think of this as a WebSocket endpoint, although it doesn't have to be over WebSockets. Where you can ask GraphQL, tell me about this thing and tell me when it changes. Okay? So first you create your schema, your types, your fields. You describe to GraphQL how your data looks, what your data looks like. You then define how you can access and how you can grab that data, how you can change it, and how you can listen to it. And then the last thing you have to do is you just wire in functions to the runtime to say, this is how you grab that information. Okay? So let's go through each one of these steps and take a look at what that really means. So schema. So we're first going to define a schema. And a schema is just a simple document, and it has a number of types in it. And the types look a lot like JSON. It's not JSON compatible, but they look a lot like JSON. And you just define a number of types. You name your types. And then those types have fields. These fields can have interesting extra things added to them. So we can add nullability information. We can add comments. There's some new extensions that are coming that allow you to add certain types of validation to those as well. So the first thing you do is you say, okay, these are all of the different types of data that I have, and these are the fields. Second thing you do with that is then you say, how do I want people to ask for this data? How do I want people to query for it? And interestingly enough, the query type in GraphQL is just a reserved type. It's not something special. So this looks exactly like when you define your types. So again, it's just a type. It's the query type. It's the special reserved type. And then inside of it, we're just defining fields, which are ways that people can query for data. And we can reuse all of the types that we've defined before, and we can provide nullability information on the return types of those queries. Okay? Then finally, we need to tell the runtime how to execute these queries, how to get this data. So we need to wire in some plain old functions to the runtime to grab this data. So in this case, if we go back here, right, we had a query. We can query for me or the current user. We can query workspaces, or we can query for a single workspace with a parameter. And if we take a look, all we need to do is say, hey, I'm giving the runtime a type wiring for the query. And whenever someone calls the workspaces query, just run this function. That's all it is. So the interesting thing about this is that this makes unit and integration testing actually really easy for your entire API. Because with these functions, you can just text those functions in isolation. And we'll take a look at that in a little bit. So what makes Kotlin a good fit for GraphQL? There's really two major things. The first thing is because Kotlin has first-class function support, there's a ton of boilerplate and a ton of ceremony that we can get rid of. So thankfully, the interface, the main interface for fetching data is this data fetcher interface in Java. And because it's a single abstract method class, we can define this just like this. Okay? The second thing is, and it's closely related, is that because Kotlin has superior type inference to the JVM, there is no type information here. We don't need it. We get all of the benefits of type safety without adding that in. So you'll see, you go back here, right? If we were to create this data fetcher in Java, we'd have to define the type in two different places, but we don't have to do that. Okay? So Kotlin really is a really great use case for this because we get all the benefits of the type information and we get all the benefits of first-class functions, which is what the runtime is really based off of. Okay? So now I'm going to do just a quick demo of what it's like to use a GraphQL API as a client, because I think this is where a lot of these things kind of start to crystallize for people. So what I'm going to do, and I have a local server that I can run, but I really like to start with just looking at the GitHub GraphQL API. So GitHub has exposed their entire API over GraphQL. It is now their preferred method for that. And one of the best things about GraphQL, and we spoke about this earlier, is that because you've given the runtime your schema document, it knows all about your types. It knows all about the relationships between your types and your data. So this is a tool called GraphQL, and it's just a little HTML web app that basically can query and introspect any GraphQL server that you want and give you an integrated API explorer and browser of the documentation. Okay? So in this case, I have a documentation explorer, and I can ask, for example, we'll see if the internet works. I can ask the GitHub API server, tell me about all the things you know about. Tell me about your schema, tell me about your types, tell me about the relationships, show me your documentation. But if I don't want to do that, I have an automated and built-in documentation explorer. So I can explore, I can say, tell me about the queries. These are all of the queries that I can run with documentation built in. And this is all generated, and this is all being run off of this information that comes directly from the API, right? You already have to write this schema document. You don't have to do any extra work to get this, all right? So now, let's take a look, and let's go ahead and look up all of the licenses that this supports. And I'm going to switch this to mirroring so that I can make it easier to type. You can still see that? Yeah, great. So let's go ahead and do this. So let's start off with this, right? So let's ask the GitHub API for the licenses, and let's go ahead and, I don't know what fields are on a license, but let's go ahead and take a look. So there's the body, the description, the featured. I don't necessarily want all these, so I'm just going to ask it for the ID and the description, okay? And I'm going to run that, and that's exactly what I'm going to get back, right? And again, the response directly mirrors the request, okay? So this is great, but how many of you have ever worked with an API where the fields maybe weren't as well named as what's in the GitHub API, right? Well, in GraphQL, if you don't like them, you can change them. So say I wanted a shorthand notation for the description, I can go ahead and add that, and I will get the response back, again, mirrored to exactly how I want it. So you can change the fields and the structure of the response to however you'd like, okay? Now, the other interesting thing about GraphQL is that maybe I'm showing a view and I need to show more than just the licenses. Maybe I'm on the homepage of my website and I want to show all of the licenses. In addition, I want to show the, the current logged in user, right? I can do that. I can ask for any amount of data I want from GraphQL in a single query. So in this case, I can go ahead and add, say, the viewer. And, well, what fields does viewer have? So viewer is a user, and it's got a number of different fields. So let's go ahead and add, say, the bio. Let's get the avatar URL, and let's say the company. So I can run this, and I'll get this information back. And I've now just pulled a completely set of unrelated data in the same exact query, customized it, grabbed only the fields that I want, and I have all of the information in a single request that I need. So this is really where the power from GraphQL starts to come apparent, is when you start to use it at a client level, right? Because you can fully customize exactly what you're getting back, all the way down to the field level, right? So I would really encourage you to think about how you are building your APIs in the future. Think about if you can integrate GraphQL into your existing workflow, your existing data. I think that by describing your schema and the workflow that GraphQL forces you to do, you are going to find that you might learn some interesting things about maybe where your API is deficient. And I think there's a lot of reasons why GraphQL could really help you make a super robust API. So that's it for me. If you have any questions, please feel free to come grab me, talk to me. I've got a bunch of different examples I've written about, both on my website and on GitHub, so you can take a look at that. That's it. Thank you very much.